how are you all? I hope you are all doing wonderful. So as you all know, the JEE Main JEE Main examinations is very near. So with this particular, I know that how important is to prepare the previous year questions, and along with that, I have come up with the JEE Main previous year question sessions. So if you have someone who is new to this particular platform and start watching this particular video from here, then I would request you to go to the playlist of this JEE Main previous year questions on different topics of mathematics and start watching it. I have already covered the two important chapters as well, straight lines and circles, and then I'm continuing with the topic of parabola. So by following this particular series, I can guarantee you that in your examination you will be mostly encountering these types or similar kind of questions. All right. So if you have prepared all of your chapters of mathematics and are looking for practice, then this is the right place to do so. So with that particular note, let's get started with the chapter of parabola. So this is my take on parabola, and I will be covering the top 10 important JEE Main previous year questions on the topic of parabola. Alright, so by doing this top 10 questions, I can guarantee you that in your examination point of in the point of view, you will definitely encounter this similar type of problems. Alright, so with that, let's get started. Now the first question I have on my screen. So if you have covered this particular chapter, I will request you for each and every problem, pause the video and try out the problem on your own, and after that tally the answers of the solution, and in the comment section do let me know how much marks are you getting on solving these particulars. All right, so with the first question in your screen is this. Basically it says that let PQ be the focal chord of a parabola, and the equation of parabola is given as y square is equal to 36, which is of length. So PQ is a focal chord. So for a parabola, if you know the parabola, which is of a general equation, that is y square is equal to 4ax, its focal chord length is, so length of the focal chord is given as 100, all right, 100 unit, and it is making an acute angle. So try to understand what all implications I'm getting from this particular question with the positive x-axis, and let the ordinate of point P be positive. Now why I am highlighting this particular, okay, let me highlight it, okay, for betterment. So I'm highlighting this sentence and I'm highlighting this sentence because many time in questions you will be, when you are solving the questions, you will get quadratic equations, and in quadratic equation, when you are having a quadratic equation, you will have more than one roots. Okay, so that means you have two roots, or maybe like a cubic equation where you will have a three roots. And now to understand which particular root will definitely satisfy your answer, you need to understand like what the question is asking on. So this acute angle, ordinate of a point P is positive. These are the implications that you must be careful of. Alright, so with this, it's saying that M be a point on the line segment PQ such that PM and MQ is basically in the ratio 3:1. Then which of the following points, now in the question it is very strictly mentioned, does not lie. Okay, so which of the following point does not lie on the line? So let me highlight it. Okay, let me use a highlighter. Okay, which of the following point does not lie? Okay, which of the following point does not lie on the line passing through M and perpendicular to the line PQ. Alright, so let me recap a little bit about the chapter of parabola. So if you know this parabola, this is the very general or form of parabola, that is y square is equal to 4ax. Okay, so if you have a parabola of this particular fashion, that is y square is equal to 4ax, then for this particular parabola, you see the parabola is like this, and for this particular parabola, the focus is at a comma 0. The focus of this parabola is at a comma 0, and the length of the focal chord is basically equal to 4a, because this particular point, the end point of the focal chord are a comma 2a, and the other end is a comma minus of 2a. Now for any parametric format on a any line or any point on a parabola can be parametrically defined by the parameter t. That means if I need to ask or represent any parametric point on a parabola, I will basically write this as p of t. That basically implies that the point is having the coordinate at square comma 2at for the parabola which is of this particular format. So in place of y, if you put 2at and x is equal to 80 square, you will find this particular relation holds good. Alright, so this is a parametric form of any point on a parabola. On a general parabola, y square is equal to 4ax. Okay, so if you have studied the chapter of parabola, you will have found out that there are there are four different types of parabola. That is y square is equal to 4x, y square is equal to minus 4x, x square is equal to 4ay, x square is equal to minus of 4ay. So there are four types. Do you need to remember for all the four? No. You just need to remember any one. Okay, for any one of the parabola, remember it and definitely apply the same concept there only by corresponding or by change of conversion. Okay, or by change of conversion in variable. All right, so this is an interesting thing. If you are someone who hasn't studied this parabola, then I would definitely request you to go through this particular what I'm speaking on. Okay, so and don't worry, I will be coming up with a full video lecture on the topic of dedicated on the topic of parabola. In that particular parabola topic, I will explain everything in detail. Okay, so for that, I'm sorry for the 2024 students, but 2025 students can definitely rely on me for the chapter parabola. All right, so let's see from here. And if I look again, and now if I analyze the equation of parabola, that is y square is 36x, so that is 4a is equal to 36. So from here I get the value of a as 9. Okay, so 9. Now it is saying that PQ is a very special chord. PQ is not a simple chord, it is a very special chord. It is a focal chord. That means, okay, it is a focal chord. That means a chord passing through the focus. So if you are saying this is the focus, so let me represent by F, focus. So it is a chord passing through the F. And we know that whenever if P has a parameter T, and if it is a focal chord, the end point of a focal chord, if represented by Q, then it will have parameter 1 minus of 1 by T. Okay, because T1, T2 has a product is equal to minus of 1. Okay, for focal chord, you can understand this focal chord simply in very similar term. That is, you assume this P as P of T1 and Q of T2, and then you apply the then you write the equation for focal chord. Okay, and then pass through this very special point a comma 0, then you will get the condition that T1 and into T2 is basically minus 1. That means if you assume the parameter of P as T, then the Q will be minus of 1 by T. Okay, so let us not waste time and let us get started with the doing. So we know that again the formula for length of focal chord. Now these chapters of conic sections are very formulatic, like theoretical. Okay, like if you understand the theoretical well, and there are some formulas relating to it. In examination point of view, the remembrance of formula is very important. So how well you are able to recapitulate and remember the formula, this will determine the how well you will be able to solve the question. So for conic section, I will definitely recommend all of you to remember the formula nicely and practice questions. Okay, so the length of the focal chord. Okay, so the length of the focal chord is given by a into t plus 1 by t whole square. So this is the length of the focal chord, and it is given in the question, it is 100. So if you look, this is what, then if you simplify, then it is t plus 1 by t whole square is basically equal to 100 by 9. So from here you will get t plus 1 by t is equal to plus minus of 10 by 3. Okay, and 10 by 3. Now there is a very important implication that it is saying that ordinate of P is positive. That means you have to look for the positive number. That means if you take T plus 1 by T, both will be positive, is basically equal to 10 by 3. Now from here you will again get a quadratic involving T and 1 by T. So if you solve this quadratic, you will get the value of T as 3 comma 1 by 3. Now which one to take? Okay, now this will also get clear when you will use the concept of acute angle that is said in the question, that the t have two values, one is 3 and one is 1 by 3. So okay, now if you assume the value of p as 3, okay, if you say the value of t as 3, then you will get p coordinate of p as and 81 comma 27. Okay, 81 comma 27, right? So you will get p as 81 comma 27, and similarly you will also get q as, okay, you will also get q as, so if you solve for it, you will get 81 comma 27. Sorry, not 27, I'm very sorry, it is into 2 also is there, right? So 9 into 3 is 27, I'm thinking like that. So it is 54, 2 into 54. And then the point q, the q will point have the parameter 1 by 3 minus of 1 by 3, because if we consider t as 3, then it will have minus of 1 by 3. And if you put minus of 1 by 3, 9 into 9, that is 1 comma 1 comma minus 6. Okay, now from here get the coordinate of p and q. Now it is said that this particular focal chord is making an acute angle. Now if you solve for t is equal to 3, then only the slope of this pq will be a positive number. That means it will make an acute angle. Okay, slope is a positive number, that means it is an acute angle. Slope is a negative, it is means the slope is making an obtuse angle, because tan alpha is positive in the first quadrant. Okay, so this will give you the result. Okay, that means t is only 3 is the favorable value. Okay, now what is asking the question? It is saying that there is a point P, point and Q, which are the endpoint of the focal chord, and there is a point M on this particular focal chord which divides this line segment PQ in the ratio 3:1. Okay, now if you solve by using the section formula, so you will get the coordinate of point M as, so 3 into, so this particular point is 81 comma 54, and this is minus 1 comma minus 6. Okay, 1 comma minus 6. So if you cross multiply and take it, it will be, and the next one will be 54 minus 18 by 4. Okay, and the result will be, so 84 by, that is equal to 21 comma 9. Okay, so this is the coordinate of M. Now M has the coordinate 21 comma 9. Now it is saying that, which of the following point does not lie on the line passing through M and perpendicular to PQ. So let me firstly calculate the slope of PQ. The slope of PQ we already calculated, and it was actually a positive value, so I didn't go forward. Okay, so it is 54 minus 6 divided by 81 minus 1. Okay, so this is the slope of the line PQ, and this came out to us as, so we solved out, and it came out as, it is coming out as, if I, sorry, I did this wrong. So 54 minus or minus is a plus, it will be 6 by 8, and it is basically equal to 3 by 4. Okay, 6 by 8 is basically equal to 3 by 4. Okay, so the slope of the line perpendicular to PQ, so the slope of the line perpendicular to PQ will have the slope minus of 4 by 3. Now the line, through M, okay, 21 comma 9 perpendicular to PQ is, has the equation y minus 9 is equal to minus of 4 by 3 into x minus of 21. Okay, so this is the equation of the line which is perpendicular to PQ and passing through the point M. Now to look for which of the following coordinate does not lie on it. Which of the following coordinate does not lie on it? So let me check for 6 comma 29. Okay, so if you put 6 comma 29 over here, so 6 over here and 29 over here, so this 20 is equal to minus of 4 by 3 into 6 minus 21 is 15. So 15, it does not satisfy, because this is last this is 20 and is equal to minus 20, it does not, sorry, it is equal to minus of 20, minus of minus 20, that is plus 20. So 20 is equal to 20, it does satisfy. Therefore this cannot be an answer. Okay, because it is saying that do not lie, do not lie. So don't miss out this particular word, do not lie on this particular line. Now let us take for minus 3 comma 43. So if you put 43 over here, so 43 minus 9 is basically equal to 30. 43 minus 9 is equal to 34. Okay, so 34, and the right hand side will be minus of 4 by 3 into 3 minus 21 is 18 into, that is minus of 24. So 24 is not equal to 34. Okay, so that means this particular point does not lie on the line or the equation of the line which is perpendicular to PQ and passing through M. That means the right answer to this particular problem is basically option number B. Okay, now I can guarantee you that there will be lot of questions where it will involve the which of the following does not satisfy this particular relation, or which of the following point does not lie on this particular line. So in conic section you will always get questions which will be asking you which of the following point does satisfy it or does not satisfy it. So be careful for this. Okay, I took this particular problem for this particular purpose because the focal chord is very important. How to take the parametric format is also important, and similarly the length of the focal chord is also important. So I hope you are able to understand how did I eliminate the more number of roots. Okay, how many roots I was getting it. Okay, so you must have understand like how to eliminate root also is a very important thing. By reading the question, like it is telling me two conditions, that it must be an acute, it must have the ordinate of point P should be positive. Okay, so from there I got the implication that the root should be taken as positive one, and that is basically T value is equal to 3. That's how I approach the problem. That's basically the importance of this particular problem. All right, so with this let us move to the second problem, and the second problem has to say that there is a basically, so it is saying that there are 3 points A, B and C which are the midpoint of the sides of a triangle with in center at D. So these are the midpoints of a triangle. So let me assume a triangle, as X, Y and Z. Okay, so there is a triangle X, Y and Z. Okay, this is Z, not Y. All right, so I have a triangle which is coordinate are X, Y and Z, and it is saying that the midpoint are basically, this point is A, that is 0 comma 1, this point is B, that is 1 comma 1, okay, 1 comma 1, and this point is C, that is basically 1 comma 0. So you can definitely calculate for the other coordinate as well. Okay, now it is saying that these are the midpoint of this triangle with the incenter at point D. So incenter of this particular triangle is at point D. So the incenter is at D. What is incenter? So if you inside a triangle, if you prescribe a circle, okay, or you inscribe a circle, then you basically get the incenter, and it is formed out by, from this particular point D, if you put the perpendicular, you'll basically get the, okay, you get the incenter coordinate, okay, from point D if you put the perpendicular. All right, so this is the incenter, and it is saying that the focus of the parabola y square is equal to 4x passes through that point D. Okay, so it is also saying that the focus of this particular parabola, so the parabola is basically y square is equal to 4x. I took this particular problem because there is not much concept of parabola involved, but this problem involves the concept of straight lines or the coordinate geometry that we studied in the initial lectures. Okay, so the if you know the following thing, that it is saying me that it passes through the point D, and the focus is basically is equal to alpha plus beta root 2 comma 0, okay, alpha plus beta root 2 comma 0. All right, so from here what I can do now, for getting the incenter we have already studied the formula, but before looking for the formula we need to find the coordinates of x, y and z. All right, so let us assume the coordinate is a comma b, okay, a1 comma b1, a2 comma b2, and this is as a3 comma b3, okay, a3 comma b3. Now the midpoint formula, if we apply, a1 plus a2 is equal to 0, and that means a1 is equal to minus of a2, okay, and b1 plus b2 is equal to 1, sorry, b1 plus b2 by 2 is equal to 1, that means b1 plus b2 is equal to 2. So and from here again you will get like different equations. So if you solve for the equation, let me write the equation down, okay, nicely. So you got the first equation, a b1 plus b2 is equal to 2, and a1 plus a2 is equal to 0. Similarly, you got the equation a1 plus a3 is equal to 2, and b1 plus b3 is equal to 2, because it's also 1. All right, now again you got the equation as a2 plus a3 is equal to 2, and b2 plus b3 is equal to 0. Now if you solve for all these particular equations, now you can solve this particular equation as, now if you take all the a1, a2, a3, if you add all a1, a2 and a3 values, that will get 2 times of a1, a2, a3, a1 plus a2 plus a3 is basically will be equal to 4, and from here you will get a1 plus a2 plus a3 is equal to 2, and we already know a1 plus a3 is equal to 2, and that means a2 is equal to 0, and if a2 is equal to 0, then if a2 is equal to 0, then a1 will be equal to 0 also, and if a1 is equal to 0, then a3 must be equal to 2, and this will satisfy the equations, okay. And in the similar fashion you can also found for b and b1, b2 and b3. So we'll get b1 as b1 is equal to 2, and b2 is equal to 0, and b3 is equal to 0. All right, so you got the coordinate of the all the triangle endpoint, all the coordinate of the triangle, okay. This was basically 0 comma 2, this is basically equal to 0 comma 0, and this is equal to 2 comma 0, okay. So you got the endpoint of the coordinate. Now we have to find for the point D. Now you already know a formula for finding the incenter of a triangle, that is basically, that is a into, and what are the side lengths, okay, we also need to find the side lengths. So let me find the side lengths, okay, length of the sides. So that this particular side length is basically equal to, this particular side length is equal to 2 root 2, and this particular side length is equal to 2. Okay, now if you calculate a into x1 plus b into sorry, I mean to a and b and c are basically sides of the three sides of the triangle, length of the three sides of the triangle. So a into x1 plus b into x2 plus c into x3 divided by a plus b plus c, comma, a into y1 plus b into y2 plus c into y3 divided by a plus b plus c. So that's how you basically calculate the incenter. So if you calculate, it will be coming out as 4 by, so 2 plus 2 root 2 divided by 4 pi. So you will also calculate the numerator term will come as 4 in both the scenario. So you calculate, it will again come at 4 plus 2 root 2. All right, so you get the coordinate of the point D. Now D is also said that it is the focus of the parabola, and it is given as alpha plus beta root 2 comma 2 comma 0, okay. So from here if you see the point D as, so if you see the point D, it is basically, if you cancel it 4 in the by 2, okay, so this is 2 plus root 2 comma, this will again be 2 plus 2 root 2, okay, 2 plus root 2. So this will, if you factorize, if you can definitely factorize it by multiplying with 2 minus root 2 in numerator and the denominator, and you will get it as, so 2 minus root 2 comma 2 minus root 2, okay. So these are the coordinate of the focus, okay. Now in the parabola it is said that, now in the general parabola what we study, okay, in general parabola, so it is a point of the coordinate D, okay, and it is saying that the if the focus of the parabola passing through D, oh, I am very sorry, it is saying that the focus of the parabola, okay, so focus of the parabola passing through D, okay, it is saying that the focus of the parabola which is passing through, the focus of the parabola passing, so a parabola which is passing through D has the focus as alpha plus beta root 2 comma 0, okay, so that's the implication of the question. So there is a very important thing that you must read the question many number of times to understand what it is asking, okay. So it is saying that this, a parabola which is passing through this particular point D has the focus at alpha plus beta root 2 comma 0, then find that particular value of alpha by and beta, then you calculate alpha by beta square, okay. So now if I assume the parabola as it was given in the mention in the question that y square is equal to x, but so if I satisfy for the y and x, so if I satisfy for y and x, that is 2 minus root 2 whole square is equal to 4a into 2 minus root 2, okay. So if you solve this, you will get 4a is equal to 2 minus root 2, therefore a is basically equal to 2 minus root 2 by 4, okay, 2 minus root 2 by 4, and therefore a is equal to half minus 1 by root 2, okay, half minus 1 by root 2, or you can write as half minus root 2 by 4, because it is said that a is basically the a comma 0 is the coordinate of the focus, and a comma 0 is basically alpha plus beta root 2 comma 0. So from here you will get alpha value as 1 by 2 and beta value as also as minus of 1 by 4, okay. Now from here if you calculate the expression alpha by beta square, so if you calculate the expression alpha by beta square, you will get it as, so it will get it as 8, so the value will be equal to 8, okay. With this, right answer to this particular problem is equal to option number D. I hope this particular discussion is clear, so you can understand that how beautifully it had the both the concepts of parabola as well as the straight lines or the triangle concept or properties of triangle. All right, so this was a pretty simple question, okay. Now let us move further and study the other problems. So the next problem we have on our screen is basically a problem on parabola. It is saying that R is the focus of a parabola, y square is equal to 20x. So I write the equation of the parabola, y square is equal to 20x, and the line y is equal to mx plus c intersect the parabola at 2 points P and Q. So if you look at the parabola, okay, so if you look at the parabola is has y square is equal to 20x, okay, so the parabola is equal to y square is equal to 20x, and the line PQ, okay, so then let this be a line P and Q, okay, so line y is equal to mx, so this is a line which has the equation y is equal to mx plus c intersect the parabola at P and Q. Now it is saying that G 10, 10 be the coordinate of the triangle PQR, so this is R, so let me assume this is R is the focal point, sorry, not the focus of the parabola, so R, and let me complete this particular triangle, then I get the center of the triangle, the centroid of the triangle G is given by 10 commas 10. Now it is also said that C minus M is equal to 6, it is also said that C minus M is equal to 6, then find the value of PQ whole square, that means the length of the focal chord whole square of the length of the focal chord. Now for satisfying the equation of line in the parabola, so the firstly let me eliminate the value of x as y minus c by m. So x is equal to y minus c by m, and if I put x in the equation of the parabola, y squared is equal to 20x. So before doing so, let me also find the what is the focus. So focus of the parabola is basically 5 comma 0, okay, so that's the coordinate of point R. Now for in this particular, if I put the value of x, I will get two values of x, and that will be the corresponding values of the x coordinate of P and Q, okay. So from here if I put y square is equal to 20 into y minus c by m, okay, so y square is equal to 20 into y minus c by m, okay. So from here you will get a definitely a quadratic equation, and the quadratic will look like 20 y square minus 20 by m y plus 20 by m into c is equal to 0. So this is a quadratic equation. So let me label this as equation number 1. Now it is said that it is very well mentioned that from here you will get two roots, that is y1 and y2. Okay, now this is a very important type of problem. Okay, because lot of students get overwhelmed or how to calculate the y1 and y2 from here. You don't have to actually calculate y1 and y2 from here. Instead, you can use the concept of sum of the roots and product of the roots. Okay, so but in since you need the centroid, so you only need the sum of the roots. So from here, you know the y coordinate of centroid. Okay, so this is the y coordinate of centroid is basically given as sum of all the xi divided by 3. Okay, or you can write it as y1 plus y2 plus y3 by 3. Okay, and you already have the y coordinate of r as 0. So it will be y1 plus y2 plus 0 divided by 3. Because, so if I am saying that the p has a coordinate, some x coordinate and y1 as y coordinate and q has some x coordinate, y2 as the x coordinate, okay, sorry, z coordinate, then from here, okay, so from here I will definitely get, okay, what I will get, I will get the sum of the roots as the roots as 20 by m. So this will be equal to 20 m by c, sorry, 20 by m, okay, 20 by m. So this will give you the result 20 by m by 3. Okay, so 20 by m whole divided by 3, that will be 20 by 3m. So this is the centroid and the y coordinate centroid is equal to 10. So from here you will get the value of m as 2 by 3. So from here you will get the value of m as 2 by 3. Now if you got the value of m as 2 by 3 and you also already know an equation, that is c minus m is equal to 6. Okay, c minus m is equal to 6. Okay, c minus m is equal to 6. So from here you can solve for c as 6 plus 2 by 3 and that will be equal to 20 by 3. Okay, so c value you got it as 20 by 3. Now if you have c and m, you can complete this particular equation. Okay, now why you need to complete this particular equation? Because you need to find for the length of pq. Okay, pq, and pq is not a focal chord. Okay, so you cannot directly apply the formula, but from here I can definitely, now if I, since I have the value of m and c, I can definitely form the equation, that is y square minus 20 by m. So m is equal to 2 by 3, that is basically will be equal to 30 y minus, okay, sorry, plus 20 by m into c, 20 by m into c. So this will again become equal to, 20, which is equal to 0. Okay, sorry, 200, which is equal to 0. So from here I'll get the factor as y minus 20 and y minus 10 is equal to 0. So with this I will get the y coordinate as 20 comma 10. So the py coordinate is 20 and qy coordinate is 10, or maybe vice versa of that. And similarly corresponding to y is equal to 20, you will also get x is equal to, so y is equal to 20, you will get x is equal to x is equal to 20 only. Okay, because 20, yeah. So and similarly corresponding to x is equal y is equal to 10, you get x is equal to 5. Okay, x is equal to 5. So because the equation of the parabola is y square is equal to 20x, so from here I got the value of p coordinate as 5 comma 10 and, or any one of that. Okay, you can label both of them as p and q and vice versa of that also, and other coordinate as 20 comma 20. So from here if I have to calculate the square of the length of the pq, this will be equal to 20 minus 5 whole square plus 20 minus 10 whole square. Okay, so this will be 225 plus 100 and the value will be equal to 325. So the answer will be 325. So the answer to this particular problem will be equal to 325, that is option number B. I hope this particular discussion was clear. Alright, so with this let us move to the next problem, and the next problem is again a important problem, okay, which basically teaches you how to construct a parabola with a given focus and directrix. Okay, now before starting it, what is directrix? Okay, so if you have x is equal to 0 and this is x and y, so if you have a parabola with the kind of parabola, okay, so but since this parabola has a focus which is minus 1 by 2 comma 0, but in case of general parabola, let us assume a general parabola y square is equal to 4ax. Okay, so if I have a parabola y square is equal to 4ax, so for this particular parabola the value of minus a comma 0 is the value of the directrix. Okay, this is the directrix. Now, what is the directrix? It is a locus of the point such that it is related to director circle. Yeah, the focus of the point for which the intersection of our two tangents are basically at an angle of 90 degree. Perpendicular intersection of tangents, the intersection of perpendicular tangents will form all the locus of the point of where the intersection of perpendicular tangents occur is basically the directrix. So in case of parabola, it is basically a line, uh, and in case of an ellipse, it is also again an ellipse. And similarly, in case of an hyperbola, it is a circle. In case of an circle, it is also again a circle. All right. So that depends. Okay. Now we have given the parabola equation. So what we know that y square is equal to 4x. So a is the coordinate of the focus. So from here you had the coordinate as. So you have the coordinate of a as minus of 1 by 2. So from here you can definitely understand. And since this particular focus is a directrix, this particular parabola, sorry, this particular parabola has a directrix y is equal to minus of 1 by 2. Okay, this particular parabola has a directrix equal to minus of 1 by 2. Okay, so the directrix y is equal to minus 1 by 2. So this particular parabola has a directrix like this. Okay, and the focus of the parabola is minus of 1 by 2. So somewhere like around this. Okay, so focus is here somewhere around this. Okay, so this is not a very general parabola that you can definitely see, but this parabola is something like. Okay, so let me find out how can we get to the parabola. So when what we know, we just need to use some transformation. Okay, so instead y is equal to y plus 1 by 2 is equal to 0, and similarly the focus is x is equal to half. So x minus of focus. So from here you can also deduce another important equation, that is y with the directrix and x with the focus. Okay, so that's how basically you can also write the equation of parabola. So in this case, if I have the focus and the directrix, so what we can also imply that from the directrix and the focus, the distance of the focus and the directrix is basically equal to 2a. Okay, 2a. So from that you get to the value of a. Okay, but that's a general case. So if you solve it for, so you have the focus as minus of 1 by 2, so x minus of minus 1 by 2, that is plus half whole square is equal to y minus. Okay, so y minus, it will be basically equal to y minus of minus 1 by 4. Okay, because I just need to find the center of the this particular hyperbola, sorry, parabola. All right, so what we can know, if the center of the parabola is, instead of it is origin, it is shifted to some a and b, I can get the equation of parabola as y minus b whole square is basically equal to 4a times of x minus, and this is a dash. Okay, x minus a. Okay, so if this particular parabola has a parabola with center at a comma b. Okay, now if this part, we just need to calculate for center. Okay, so how we calculate for center? So as we can see, the directrix. Okay, so the directrix point is basically y is equal to minus of 1 by 2. Okay, so the directrix is basically y is equal to 1 by 2 minus of 1 by 2. Okay, so y is equal to minus of 1 by 2. Okay, so this is, and the focus is basically, sorry, minus of 1 by 2 comma 0. Okay, so the focus is something like this. Now let us find this perpendicular distance. Okay, the perpendicular distance. So what will be the perpendicular distance? Okay, so what will be the perpendicular distance? The perpendicular distance will be equal to 1 by 2, and we know that the perpendicular distance of the focus and the directrix is basically equal to 2a. So 2a dash in from here. Okay, 2a dash. So 2a dash is basically equal to half. So from here you get the value of a as, so from here you get the value of a as 1 by 4. Okay, so you got the value of a dash as 1 by 4. Okay, and also you get the value of a dash as 1 by 4, so therefore 4a dash is basically equal to 1. Okay, and since this parabola has a directrix as y is equal to minus of 2x, this particular parabola is of the format x square is equal to 4ay. Okay, so that particular format. So if you look for, now from here you just need to find the center. The center of the parabola is basically the midpoint of the line joining okay, of the line joining the focus and the intersection of the axis of the parabola with the directrix. Okay, so what will be the axis of the parabola? Okay, so that's how we basically get to the center point of the parabola. Okay, so this is an important type of problem, that's what I'm just trying to imply. So you will get the parabola equation something as like this. Okay, So if you solve for the with this particular given conditions, you can get the parabola equation as x plus 1 by 2 whole square is equal to y plus 1 by 4. Okay, y plus 1 by 4. Okay, so that will be the equation of the parabola. So that will be the equation of parabola. Now if you solve and simplify, you'll get y is equal to x square plus x. Okay, y is equal to x square plus x. So this is the equation of the equation of the parabola. So that means this particular parabola can also factorize into x plus 1. So that means this particular parabola has a root 0 and 1. So like this particular parabola. Okay, so this particular parabola is of the origin like this. Okay, and the directrix. So if this is the okay, so this is the center of the parabola, and the directrix is something like this. Okay, and you have the focus somewhere here around here. Okay, so you have the focus here. So with the focus as minus 1 comma 0, minus 1 by 2 comma 0. Okay, and you have this particular distance as 1 by 2. Okay, so you have to just consider the line. You have just to consider the line x is equal to minus of 1 by 2 as the axis of the parabola, and consider this line as the axis of the parabola, and intersection point with the directrix, and the intersection point with the directrix will give you minus of 1 by 2 comma, so the directrix value is also minus of 1 by 2. Now if you have these values, so you can definitely find out the midpoint. The midpoint will be minus 1 by 2 minus 1 by 2 divided by 2, that will be minus of 1 by 2. So the center of this parabola is basically minus of 1 by 2, and the other center will be minus of 1 by 4. So the center of the parabola, you got it. So if you have the center of the parabola and you also have the value of the 4a dash value, then you can definitely write the equation of the parabola. And the equation of the parabola is basically found out as y is equal to x square plus x. Okay, x square plus x. Now it is asking the question, then you have to find for the, then S is basically set of all x belongs to real number such that tan inverse of root under of a function of x plus sine inverse of root under of function of x plus 1 is basically equal to, so you have to look for the equation that is tan inverse. Now it also involves ITF functions. Okay, so tan inverse of root under f of x is basically this particular parabola. Okay, x square plus x plus sine inverse of root under x square plus x plus 1. Now this is a very general pattern question. Okay, now for firstly, whenever you have a question on ITF equation, you just need to look for whether this particular parameter inside this function does satisfy the domain or not. What we can understand, because a tan inverse domain is not need to be basically checked, we don't need to check for the tan inverse domain. What we need to check is basically the domain of sine inverse of x. So sine inverse of whatever is present in the function inside, it must be less than or equal to 1 and greater than or equal to minus 1. That means, so if you look at this particular value, so this particular value for x belonging to real number, x square is always a positive number, and similarly x plus x square plus x plus 1 will be a number, will must be for having this equation, it must lie between 0 and 1, because it's also square root function and square root cannot take negative value. That means this particular inside one will always take a value between 0 and 1. Okay, it's both included. Okay, similarly because, and similarly also x square plus x must be positive number, must be a positive number. Okay, so if it is a positive number, and it must lie between 0 and 1. So from here there are only one implication cases, only one case is only possible for this particular scenario, that is so from here I can write this particular equation, I can solve and write that x square plus x, it will be less than 0 and greater than minus of 1 by 2, greater than minus 1. Okay, and it is also saying that it must be greater than equal to 0. It is greater than equal to 0, and it is saying that it is greater than equal to minus 1 but less than 0. That means this both equation can only be satisfied, when the value of x square plus x is equal to 0. Okay, now if you solve for x square plus x is equal to 0, you will get the roots as minus 1 comma 0, minus 1 comma 0. All right, so you get to the two values. That means the set S contains two elements. Okay, the set S contains two elements. Okay, therefore the set S contains two elements. Okay, so which is the right answer will be exactly two elements. That means option number C will be the right answer. All right, so this is the important type of problem, because it involved formulation of the parabola as well as solving the ITF equation. All right. So with this, let us move to the another important problem, and this is a very common set of problem that is asked in JEE Mains, JEE Advanced, WBJE, and different state board examination. Okay, the concept of common tangents. Okay, so it is saying that if if point A is a point on the x-axis and the common tangents are drawn from A to the curve. Okay, so let me draw the curve. The first curve is a circle and second curve is a parabola. So if you have this parabola, okay, if you have this parabola, the parabola equation is y square is equal to 16x with the focus at 4 comma 0. Okay, and similarly the circle is basically of radius 2 root 2, 2 root 2 units. So you can have the circle somewhere like this because the focus is of 4 comma 0, and this particular endpoint is basically 2 root 2 comma 0. So 2 root 2 is basically some 3 point something around. Okay, so and the other end will be minus of 2 root 2. So this is a circle and this is a parabola, and there is a point A on the x-axis from where the common tangents are drawn. So if tangents are drawn, so this is a common tangent. Okay, this is a common tangent. Similarly, there will be two possible cases of tangent. There will be two possible cases of tangent. Okay. Oh. Okay, don't go by diagram. Okay, I'm trying my best. Okay, so these are the two possible set of tangents that can be drawn from A. This is a straight line. Okay, don't go by my diagram. Again, I'm saying. Now, what you can do to solve question on common tangent? Okay, the only thing to solve the questions of common tangent is basically an implication of comparing the equation. So for the parabola, y square is equal to 4ax, that is basically given as 16x. So from here a is equal to 4, and we know that the general equation of tangent. So since we do not have the point where the tangent is drawn, we can definitely write the equation of tangent in slope format. Okay, in slope format. So there are three formats. One is the point approach, one is the slope approach, one is the parametric approach. We can definitely use parametric or slope, any one of that, but it is better to use slope format because for the slope format I will say you that whenever you take this particular important geometrical condition, you basically get advantage, or you can do on this parametric format as well. So if in slope format, we know that the equation of the tangent is basically y is equal to mx plus a by m, and this will give you mx plus a is basically 4 by m. Okay, 4 by m. So this is the value of the this is a common tangent for this particular circle and the parabola. That means for the condition of a tangency for a circle is basically that a tangent is such a line that from the origin of the circle, okay, so from the origin of the center of the circle, from this particular case the circle center is basically 0 comma 0. So if you drop a perpendicular on the circle, on the straight line of that particular straight line, which is such known as tangent, is basically this particular distance will be equal to the radius of the circle. So as you can see, for the radius of the circle is basically equal to 2 root 2. Okay, for circle x square plus y square is equal to 8. Now for this particular circle, if this radius is 2 root 2, that means the perpendicular drop will be basically equal to 2 root 2. The value of the perpendicular drop from 0 comma 0 will be equal to 2 root 2. Now the equation of the tangent was y is equal to mx plus 4 by m, and the perpendicular distance r is basically equal to 2 root 2 is equal to mod of, now put 0 comma 0 in this particular equation, or let me take y on this particular side and equal to 0, and then you put 0 comma 0, you will get the value as 4 by m divided by square root of m square plus 1 modulus. Okay, now you can simplify this equation, that is 4 by m into root under m square plus 1 is equal to 2 root 2. So if you cancel out 2 root 2, you will get root 2 left over here. Okay, because this is 2 root 2 into 2 into root 2 is basically 4, so there will be 2 root 2 left over here, and there is root 2 is equal to m into root m square plus 1. So from here you can definitely imply that the value of m is basically equal to plus minus 1. So the value of m is basically equal to plus minus, because if we remove this modular sign, it will be plus minus root 2. That means the m value can have both values, that is plus minus 1. This basically implies that there can be two possible common tangents to the circle and a parabola, and that is basically shown in the diagram as well. So if you see in the diagram, because of the symmetriness, there will be two possible common tangents. Because of the symmetry, there will be two possible common tangents. And from here, so if you write the equation of the common tangent, the equation of the common tangent will be equal to x plus 4 and other equation will be minus x minus of 4. Okay, so these are the two equations of the common tangents. Okay, the two common tangents will be x is equal to, sorry, y is equal to x plus 4, and other tangent will be y is equal to minus x minus 4. So you can take any one of that. Okay, now you have to solve for if one of the tangent touches the two curve. Okay, if one of the tangent, okay, if one of the tangent touches the two curve at q and r. So what is q? Now it is saying that two curves at q, so first curve at point q and the second curve at point r, then you have to find for the distance qr whole square. So this is very simple. So you know that the point of tangency for a parabola, okay, the point of tangency for with the parabola, okay, and the, you can definitely go on solving this equation in the parabola. You will get have 2 points. Okay, you can take any one of them and solve for it, or you, if you know the point of contact of the point of contact of the tangents to the parabola as well as circle, you can definitely solve for it. Okay, so that's also another way to solve it. Okay, now taking one of the tangent as, if I take the tangent as y is equal to x plus 4. Okay, and the point of, and the point of tangency, okay, and the point of tangency, so I have to look for the point of the point of intersection with the parabola y square is equal to 16x. Okay, y square is equal to, drawn from A to the curves, and if one of the tangents touches the two curve at Q and R. Okay, yeah. So I have to just solve for it. So let me solve for that. And in place of y, I put x plus 4. So I will get x square plus 16 plus 8x is basically equal to 16x. So from here, I'll get x square minus 8x plus 16 is equal to 0. This will give you x minus 4 is equal to x whole square is equal to 0. That will give you x is equal to 4. So you got the x coordinate of R. So you got to the x coordinate of R as 4, and the y coordinate of r will be definitely, so if we put 4 over here, it will be 64, that is 8. Okay, so it is positive, so 4 comma 8. And similarly for the circle, so if you solve for the circle, that is x square plus 16 plus 8x is equal to 8. So you will get 2x square plus 8x, okay, plus 8 is equal to 0. So from here x square plus 4x plus 4 is equal to 0. So from here x minus x plus 2 is whole square is equal to 0. Okay, I, I do assume that I have solved it correctly. Okay, so from here x is equal to minus 2. That means the coordinate of point Q will be given as minus 2 comma, so minus 2 comma, and if you put 2 4, and this will again be equal to 2. Okay, so this will be minus 2 comma 2. Now I have to calculate for the square of the distance of AQ. That means minus 2 minus 4 whole square plus and 2 minus 8 whole square. So that is equal to 36. 36 plus 36. So that is equal to 72. Which is the right answer to this particular problem will be option number D. Option number D is the right answer. I hope this particular discussion was clear. Alright, so this was a pretty simple question. Now another simple question that you can also face. Now this question is also very important because this question involves the concept of AMGM. Okay, sorry, APGP. Alright, so this is a very beautiful question because people do get overwhelmed whenever there are questions solving this particular problem in the examination temperament. Okay, so what I will suggest you to solve the question in the examination temperament by the way I am solving it. Okay, it is saying that two parabolas, the parabola equation are not very simple equation. Okay, these are the two parabola, not the general equation of parabola that we generally see. It is saying that two parabolas basically intersect on the line y is equal to 1. That means this particular parabola will have the intersection point, the point of intersection. So how I'm thinking is the way you must also think. The point of intersection of the parabola is alpha comma 1 because the y coordinate will be fixed in equal to 1. So the point of intersection of this parabola is basically alpha comma 1. Okay, now if this is alpha comma 1, then this particular value will satisfy this both the equation. So from the first equation it will be a alpha square plus 2b alpha plus c is equal to 0 is the first equation, and similarly d alpha square plus 2e alpha plus f is equal to 0 is the second equation. Okay, now from here, from the first equation, now it is also said that a, b and c are basically in GP. So when three numbers are in GP, then they basically satisfy a relation b square is equal to a into c. B square is equal to a into c. Okay, so they satisfy the relation b square is equal to a into c. Now in the first equation, if I put in place of b, that is a alpha square, and in place of b if I put root under ac, then I will get 2 root ac alpha plus c is equal to 0. Okay, Now what I can do, I can factorize this particular in a perfect square. As you can see, I can factorize it as root a alpha minus root c, sorry, not minus, it will plus root c, root c is basically whole square is equal to 0. Now from here I will get the value of alpha as minus of root under c by a. So if I get the value of alpha as minus of root under c by a. Now if I put the value of alpha in the second equation, if I put the value of alpha in the second equation, I will get it as d into c by a, okay, plus 2e into 2e into, okay, it will be root under c by a, okay, plus f is equal to 0. Now from here I can do another mathematical jugglery, that is d by a. Now why did I do so? Because if you look at the question asking for whether the answers, if you see the answers in the first two option, it is asking me whether d by a, e by b and f by c, the same options are there, are in AP or are in GP. That means I have to look for d by a. So if you eliminate c from here, the terms will be coming out as d by a, okay, there will be minus sign, okay, minus sign, minus 2e by, so if you divide by c, you will get root c in the denominator, that will be basically b, because b is equal to root under ab, okay, root under ac, that will be root under ac, and ac is equal to b, plus f by c is equal to 0. So from here you can see another magical relation, that is 2 times of e by b is equal to d by a plus f by c, that is the condition of a AP. That means d by a comma e by b comma f by c are in a special relation, that is basically arithmetic progression. So with this, is the option number A is the right answer to this particular problem. I hope this particular problem was clear. So with this, let us move to the eighth problem, and the eighth problem is again a very important problem. Okay, it is saying that h comma k be a point on a parabola. Okay, it is saying that h comma k is a point on the parabola, x is equal to 4y square, which is nearest to the, and h is such a point which is nearest to the point q, that is 0, 33. Then the distance of p from the directrix of the parabola, y square is equal to 4x plus y. So you just need to look for the parabolic equation. Okay, so if you know the equation of parabola, then you can definitely look for. And here is a very important concept, that is the point of nearest distance. Okay, so you know that the shortest distance definitely occur along the normal, along the common normal. Shortest distance between two curves always occur along the common normal. So I will write this particular very important condition. Okay, so I will write it as a note. Okay, the shortest distance, between two curves or occurs occur occurs along the common normal. Okay, along the common normal. So this is a very important thing. That means for the two parabola, you just need to look for the equation of normal. Okay, so if you look at the first parabola or the second parabola, so it is asking me that you have to find the distance of point P from the directrix of the parabola, this particular parabola. So let me decode the second parabola. Okay, the second parabola is basically looking on the format y square minus 4y is equal to 4x. Okay, so now what I need to complete this perfect square is basically I will add plus 4 to both the sides. And if I add plus 4 to both the sides, then I will get it as y minus 2 whole square is basically equal to 4 into x plus 1. Okay, now you know that the equation of the, so this is the equation of parabola whose center is basically at, so if you draw this parabola, the center of the parabola basically will be at 2 comma minus 1. Okay, the center of the parabola will be 2 comma minus 1. So from 2 comma minus 1, if you draw the parabola, this will be the parabola, okay, with a shifted center. So for this particular parabola, the equation of the directrix will be equal to, okay, now for the equation of directrix, you just need to look for, so in normal equation of parabola for y square is equal to 4x, the directrix equation was y is equal to minus of a. That means for this particular parabola, instead of y, it will be y minus 2, which is equal to minus of a, and a value is equal to minus 1. A value is equal to 1, so minus of a, that means minus 1. So from here y is equal to 1. So that is the, so y is equal to, oh, I'm very sorry for the wrong thing. Okay, directrix, it is asked directrix. Okay, so whenever we are finding directrix for a parabola, it is basically x is equal to, so directrix is basically x is equal to minus of a. Okay, sorry, because x is we have line which is perpendicular to the x-axis. X is equal to something is a line perpendicular to x-axis and parallel to y-axis. Yes, so that particular line will be equal to x minus 4 is equal to minus 1 and x is equal to, so the line equation of the directrix will be equal to, oh sorry, I'm doing a lot of mistakes. Okay, so these are the mistakes that you must avoid in the examination. So y x is equal to minus of 2. So that means x is equal to minus of 2 will be the directrix for this particular parabola. So this is the x is equal to minus 2 line. Okay, so the x is equal to minus 2 line is the directrix of the second parabola. Now it is saying me that for this particular parabola, for the parabola, for the parabola, x is equal to 4y square. Now you have to look for the h comma k point, which is basically nearest to the point q. That means this nearest point or q, the h comma k to q will basically occur along the common normal. That means the common normal will satisfy this q as well as p. Okay, so let me find firstly write the equation of normal, equation of normal. Okay, for like with the parameter t. So we know that the equation of normal for this particular parabola, that is y square is equal to 1 by 4a is equal to y is equal to minus of tx, okay, plus 2 into 8. Okay, so this is equal to t by 16. Okay, plus 80 cube, that is basically a, what is the value of a from here? A value is basically 1 by 4 by 4, that is 1 by 16. Okay, so that is plus 280 plus 80 cube, so t cube by 16. So this is the equation of the normal. Now this particular equation of the normal will pass through the point 0 comma 33. Okay, because it is nearest to h, because it is saying the nearest point, okay, that means the shortest distance, nearest point h comma k. That means this 0 comma 33 will satisfy, that is 33 is equal to, t by 8 plus t cube by 16. Okay, so from here I'll get the relation as t cube plus 2t is equal to 520, 528. Yes, 528, 16 into 33. Okay, I did it as 16 32 and added as 16. Okay, so it is 528. So from here you get a cubic equation, that is p cube plus 2t is equal to 528. Now if you can instead of solving this cubic equation, you can definitely figure it out that if you put t as 8, the t cube value basically comes nearest to 500 something. Okay, 500 and what is the t cube value? It is basically 512. Okay, yeah, it is 512. So 512, and if you put t as basically 8, then that means the value, this particular equation satisfies. That means the value of t is equal to 8. So if t is equal to 8 and h is a point on the parabola, that is, sorry, p is a point on the parabola, then it can also be written as in parametric form, because p I consider it as a parametric form as at comma 80 square comma 280, and in this parametric format only I draw a normal, I drew the normal from p. So that means in t I got as 8. That basically means in place of 80 you put in place of a you put 1 by 16 and t as 1 8. So you will get p as 1 by 2 comma, so you get p as 1 by 2 comma, and 2 into 1 by a, you will get 1 by 2 comma 1, and you have to find the distance of this particular line from the equation of the line, that is x plus 2 is equal to 0. So what is the perpendicular distance? So perpendicular distance from x is equal to minus 2. So the distance, perpendicular distance. Okay, so what was the value of a? It is 1 by 16 into 64. Okay, sorry, 1 by 16 into 64 is basically 4 comma 1. So this will be 4 comma 1. Okay, 4 comma 1. So the value that is asking me for the distance of the point p from the directrix of the parabola is basically equal to, so if you find the distance, if you find the perpendicular distance of point 1 4 comma minus 4 comma 1 from the equation of the line x is equal to 0, x plus 2 is equal to 0, so we get the distance as if you find the distance, so this will be 4 plus 2 divided by 1, so this is 6. The option is option number C. Okay, so this is the right answer to the particular problem. Another very simple problem. Okay, with this let us move to the Next problem, and the next problem is basically it is saying that if the tangent at point P on the parabola, okay, it is saying the tangent at the point P of the parabola y square is equal to 3x is parallel to the line. That means it is giving me the slope of the parabola, slope of the tangent. So slope of tangent is basically equal to minus of 1 by 2. That means I got the value of a as 3 by 4 and the slope value as minus 1 by 2. I can definitely write the equation of tangent. The equation of tangent for the parabola y square is equal to 4x is basically equal to mx plus a by m. So m is equal to minus of 1 by 2 plus a value is 3 by 4 into m value is minus of 1 by 2, that is minus of 1 by 2, and this will come out to as minus of x by 2 plus, and this particular will be equal to, sorry, minus of 3 by 2. So the equation of the tangent is given as minus x by 2 minus 3 by 2. Okay, now it is saying that and the tangent at q and r on the ellipse, okay, and the tangents at the point q and r on the ellipse. So there is another ellipse, okay, so it is also involving the question of ellipse, that is x square plus 4 plus y square by 1 is equal to 1. It is basically an ellipse, okay. So ellipse is like this with the endpoints as 2 comma 0 and minus 2 comma 0, and the other endpoint as 1 comma 0 comma 1, 0 comma 1 and 0 comma minus 1. So this is the ellipse. It is saying that there are 2 points on the ellipse, that is q and r, from where the tangents are drawn, and these tangents, okay, then tangents at point q and r are perpendicular to the lines, okay. So if a tangent at point P is parallel to the line x plus 2y is equal to 1, and the tangents at point Q and R are perpendicular to the line x minus y is equal to 2, then the area of the triangle PQR. Okay, you have to look for the area of the triangle PQR. So very firstly, I can get to the point P. Okay, so from here I get to the point P as, so if you know that the point of contact of a tangent for our parabola is basically given by a by m square comma 2a by m. So from here I get the point P as, 3 comma minus 3. Okay, so I get the point P as 3 comma minus 3. And similarly for the point of contact, of tangents on an ellipse, it is given by another very important lesson, minus plus of a square m by a square m plus b square comma, okay, comma minus plus b square by root under a square m plus b square. Okay, m is the slope of the tangent. Okay, now what we can see, so from here if you look at the slope of the line x minus y is equal to 2, this particular line has a slope 1. Okay, this particular line has a slope 1, and it is saying that the tangents at point q and r on the ellipse are perpendicular. So both of these particular tangents, so if you draw a tangent, these are perpendicular. So if you do the tangents, these particular tangents are perpendicular to the line. Okay, these particular tangents are perpendicular to the line. So the slope of the tangent in each of the case will be equal to 1. Okay, the slope of the tangent will be equal to 1, and if you do so in that particular format, if you do so, you'll get to the coordinate of point q and r as, so you can definitely solve it. So the coordinate of q, you can do it on a rough. Okay, you can get the coordinate of point q as minus 4 by root 5, sorry, this is a root over here, I missed the root. Okay, a square m by root under a square m plus b square. Okay, yeah, so minus 4 by root 5 by comma minus 1 by root 5, and the point r will be 4 by root 5 comma 1 by root 5. Okay, 4 by root 5 comma 1 by root 5. So I get the both the points, and if I have the endpoints of the triangle, that is a PQR triangle. Okay, PQR triangle, then I get the area of triangle PQR as half times of modulus of determinant of 3. This is 3 because P has a coordinate 3 comma minus 3 comma, okay, and so this will be minus 3 1. Q has a coordinate minus 4 by root 5 comma minus 1 by root 5. Okay, so this will be minus 4 by root 5 comma minus 1 by root 5 comma 1. Okay, and this will be 4 by root 5, and this will be 1 by root 5 and 1. So if you can simplify on your own, I can leave this task to you. Okay, you can simplify this determinant. This determinant is very simple to simplify. What you can do, you can apply some row and column transformation to make this particular element and this particular entity 0. And if you make this entity 0, and also you can take 1 by root 5 common from the second row and also common from the third row, this will make you 1 by 5. That basically will become 1 by root 10, 1 by 10. So this particular value, if you solve it, this will come out to 2 root 5 by 10 and into minus 15, into minus 15, that is the determinant value by simplification. So this will come out to as, so you can solve it on your own. This will be equal to, because after all you have to take the modulus value, okay, because the area of a triangle is not a negative quantity, because we are basically calculating geometrical area, not the algebraic area. Okay, now there is a two different thing, algebraic area and geometric area, which you will get definitely clear about when you study the topic of definite integrals. Okay, so the area comes out to 3 root 5 square units. So with this, the right answer to the particular problem is equal to option number B. Okay, so this is the option number B, which is the right answer to this particular problem. I hope this particular problem is clear. So let us move to the last problem. Okay. Oh, I do have more problems. All right, not the last problem. Okay, so, or maybe I give a one problem as a homework. All right, so that will be a wonderful thing, because I just need to see what is your participation in your works that you are basically doing up. So I can leave this particular problem, so you can study this problem, that the equation of two sides of variable triangle, x is equal to 0 and y is equal to 3, and the third side is a tangent to the parabola. Okay, so this is a very simple problem. Okay, it's not a very difficult problem, it is a problem of locus. Okay, so you can try it out. I will just give you the hints. Okay, what hint I will give you? Now it is saying that there is a parabola, y is equal to 6x, and its third side. So there are two sides of a variable triangle. Okay, a triangle whose two sides are fixed and one third side is a variable side, which is basically a tangent to the parabola. And a tangent of parabola are different points. So a tangent of parabola are different point. That means you have to follow the parametric approach. And we know that the tangent of a parabola in a parametric format is given by ty is equal to x plus a. What is the value of a? A is basically 6 by 4, that is 3 by 2, that is 3 by 2 t square. Yt is equal to x plus at square. Okay, that's the equation of the parabola, and this is the third side of triangle, and it is said that the locus of the circumcenter, you have to find for the locus of circumcenter. Now in this problem, the important thing that you need to visualize is that, so if you draw the two fixed side, that is y is equal to 3 and x is equal to 0. So this you can understand by very simplicity that these particular sides are perpendicular to each other. These particular sides are perpendicular to each other. That means if you have a perpendicular side and the variable side is like this, and you know that whenever there is a perpendicular or triangle involving a right angle triangle, then the circumcenter is very simple. That you know the circumcenter will be basically the midpoint of the third side, or midpoint of the largest side, midpoint of the largest side of the hypotenuse. So if you can understand from here, the equation is ty is equal to x plus at square. Okay, at square. So from here, if you find out the endpoints, that is with y is equal to 3. So if you put y is equal to 3, the endpoint will come out as, this particular endpoint will come out as 3t minus 3t square by 2 comma 3, and this particular point in place of x is equal to put 0, then y is basically 0 comma 3t by 2. Okay, so you get to the points, and now the circumcenter is basically the midpoint of, so if you represent this point as a, this is c, this is b, so midpoint of ac. Okay, now from the midpoint of ac you will basically get a relation involving, okay, so this will be a midpoint. Okay, but you can also try out this particular problem. Sorry, you have to look for circumcenter. Okay, circumcenter, you have to look for the circumcenter. Okay, so is it the circumcenter, right? Also you can do this particular problem by finding out the, firstly the getting the orthocenter, and the orthocenter will be basically the point b, and the point b is basically 0 comma 3. This is the orthocenter, and orthocenter, circumcenter, and the centroid. So if you write the centroid as g, is basically dividing the ratio 2:1, and this is the circumcenter, or you can call it o. Okay, circumcenter, you call the circumcenter as o. Okay, circumcenter is o. Okay, you can do this by taking the midpoint, but will give you only one particular relation, but you need to eliminate by some other relation. So that kind of relation was actually obtained by dividing the line segment circumcenter, centroid, and the orthocenter in the ratio 2:1, because this will give you an important relation. This will give you the relation that you were looking for in x and y, and from x and y, you eliminate the parameter in form of x and y, then you get to the equation of the locus, and from here you will get the locus equation. So I can reveal the answer, but I won't do it because okay, so I have established that I have given you a lot of hint for this particular problem. I hope you will try this particular problem on yourself and definitely mention me in the comment section what is the answer of this particular problem. Alright, so with this, let us move to the last problem, and the last problem is a very important problem, again a problem of common tangent. But in this case, the two curves are basically a parabola. So it is asking me that there are the distance of a point 6 comma minus 2 root 2 from the common tangent y is equal to mx plus c between the two curves x is equal to 2y square, and the other curve is basically given as x is equal to 1 plus y square. Okay, so the two parabolas, so I can definitely find out and check for the first parabola y square is equal to x by 2. So this is the first parabola. So for this particular parabola, that equation of the tangent, equation of tangent is basically y is equal to mx plus a by m. So that will be y is equal to mx plus 1 by 8m. Okay, because the value of a is basically 1 by 8. And similarly for the second parabola, that is given as x minus y is equal to y square is equal to x minus 1. So for this particular parabola, that equation of the tangent in slope format, the equation of the tangent in slope format will be given as okay, y is equal to m into x minus 1 plus 1 by 4m. Okay, now for the common tangent, you can see that only you need to equate the constant parts. For common tangent, you just need to equate the constant part, or you can solve this question by comparing the both the equations. So this is the first equation and this is the second equation, because they are the common tangent. So that means you can directly equate the constant part, that is basically equal to 1 by 8m is equal to 1 by 4m minus of m. Okay, minus of m. And if you solve it, you will get as 1 is equal to, if you can make this quadratic, you will definitely find this quadratic as 2 by 8m, and if you subtract it, it will become minus m minus uh, plus of 1 by 8m. So this will again make the quadratic as 1 is equal to minus of 8m square, 1 is equal to minus of 8m square plus 2. So from here you get to the quadratic, and the quadratic, for the quadratic you just need to find the equation of the tangent which has a slope positive. So if you have the quadratic equation as mx m 8m square minus 2 plus of 1 is equal to 0, so this equation will be equal to 8m square is equal to 1. So the value of m is basically equal to, if you take a positive one, so value of m is equal to 1 by 2 root 2. And if you have the equation as common tangent as 1 by of the slope 1 by 2 root 2, the equation will be x by 2 root 2 plus 1 by 2 root 2. You can put the constant will be a by m. So this will become the equation of the common tangent, and the common tangent equation is equal to x minus 2 root 2 y plus 1 is equal to 0. You can cross multiply, you just cross multiply it. So you have to find the distance of the point 6 comma minus 2 root 2 from this particular common tangent, and you can do it on yourself. That is d is basically, and d will be basically equal to 6 minus of minus, that is plus 8 plus 1 divided by 1 plus 8 under root, that is, and this will come out as 15 by 3, and that is basically equal to 5 by 5. Okay, that will be equal to 5. And with this, the right answer to this particular problem will be option number B. It is a pretty simple problem, but it is an important problem. Okay, now these types of problems actually get repeated in your JEE Mains paper, so you can see how simple this problem is. But people do make mistakes. Okay, people do get overwhelmed whenever whenever they take mistakes in the value of a, or they make mistake by comparing the value of the constants. Okay, so you just need to avoid those mistakes, then only you can definitely ace those problems. Okay, so with this, I came to the end of this today's discussion on the previous year top question on the topic of parabola. I gave you one particular problem as a homework, and I'm expecting the answer of that in the comment section. Also, I will be waiting for your comment of how much marks did you achieve for this particular session. Okay, so definitely comment down in the comment section. Also, you can find in the description, you will find the playlist of the JEE Mains previous year session. All right, so and with this, you can also comment me regarding whether you need some kind of short formula and tricks sessions for each and every topic of mathematics. Then I may be planning to do so. Okay, so keep following this particular JEE Mains previous sessions. So if you are new, then definitely subscribe and press the bell icon. And if you like this video, don't forget to like the video as well. So with this, I take a leave, and that's all my take on the chapter of parabola. Thank you.